Have you ever asked an AI a question and it gives you this answer that sounds so confident, so plausible, but it's just completely wrong? Yeah, that's called a hallucination, and it's a huge reason why it's so hard to trust even the most advanced AI systems. So today we're going to dig into exactly why this happens, and more importantly, what we can do about it. Right, so this is the big question, isn't it? Why do these incredibly complex language models make up plausible-sounding nonsense? Why don't they just say, hey, I don't know the answer? It's genuinely one of the weirdest and most critical problems we need to solve in AI right now. And check this out. This is a perfect example. Some researchers asked a couple of different AI models for the title of a specific dissertation. ChatGPT gives one answer, Llama gives a totally different one. And the punchline? They're both wrong. The real title isn't even close. This shows you it's not just a one-off glitch. It's something fundamental going on. Okay, so here's our game plan. We'll start by defining the hallucination problem. Then we'll dive into two big reasons they happen. One is about statistics, the other is about how we actually train them. After that, we'll look at a surprisingly simple fix, and finally, wrap up with what all this means for building AI we can actually rely on. All right, first things first, let's make sure we're all on the same page about what an AI hallucination really is. So it's that toxic mix, right? It sounds believable, it's totally false, and it's delivered with 100% confidence. It's not just getting something wrong, it's the model's choice to invent an answer instead of just admitting it doesn't know. That's what makes these things so tricky and honestly so dangerous. Now, you might think, oh, hallucinations must come from the AI learning from all the junk on the internet. And, well, that's not totally wrong, but the real problem starts much, much deeper. It's actually baked into the very statistics of how these models learn language in the first place. So, in this first stage, pre-training, the AI is just swimming in a giant ocean of text. It's not learning what's true or false. It's learning patterns. It's learning the statistical vibe of how words sound when you put them together. And that process, as we're about to see, basically pressures it to fill in the blanks even when it should. Here's the key idea from the research. Imagine you have two jobs. Job 1, come up with a true statement from scratch. Job 2, I give you a statement, and you just tell me if it's true or false. Job 2, just classifying, is way, way easier, right? Well, it turns out a model's ability to do the hard job is mathematically tied to how good it is at the easy one. And boom, here's the math that proves it. Don't worry, it's pretty simple. This formula basically says that the rate at which a model will just make stuff up is at least double its rate of getting a simple true-false question wrong. So even if a model is pretty good at telling fact from fiction, it's basically guaranteed to generate fiction at a much higher rate. It's a statistical trap. So let's just nail this down. Hallucinations aren't really a bug, they're more like a natural side effect of the statistics. Because the AI is built to generate probable-sounding text, if it's even a little uncertain about the facts, it's just going to fall back on what sounds right. And that's where the problem begins. Okay, so the problem is born from statistics, but it's our training methods that feed it and make it grow. It turns out we are literally teaching these AIs to be overconfident bluffers. The best way to think about this is that language models are like students who are always taking a test. And on this test, there's no penalty for guessing. So what do you do when you're not sure of the answer? You take a shot, right? You guess. That's the exact environment we've created for our AI. Just look at this table. These are the big, industry-standard tests, the benchmarks, we use to decide if an AI is smart. GPQA, MMLU, all of them. And look down that last column. Do they give any credit for saying, I don't know? Nope, not a single one. You get points for being right and 0 for being honest about your uncertainty. There is 0 incentive to not guess. And this is the result. This is the proof. These are called calibration curves. On the left, we've got the raw pre-trained model. See how its confidence, the bars, pretty much matches its actual accuracy, the dotted line. It's pretty honest. But now look at the chart on the right. After we train it to pass all those tests, its confidence is through the roof, totally disconnected from reality. We've taught it how to bluff. So the bottom line is our entire evaluation system is fundamentally broken. We're taking these models that start out reasonably well calibrated and honest, and we're training them to become overconfident liars because, hey, that's what gets the high score on the test. Okay, so if the problem is baked into the statistics and then made worse by the rules of the game we make AI play, how on earth do we fix it? Well, the proposed solution is actually pretty brilliant, and it's not some crazy new algorithm. We just need to change the rules of the game. This isn't just a technical problem, it's a socio-technical one. It's about the culture of how we measure success. We have to stop rewarding the behavior we hate, bluffing, and start rewarding the behavior we want, which is honesty. And this is how you do it. You just change the instructions. It's like those old SAT tests, remember? You introduce a penalty for wrong answers. With this simple rule, guessing suddenly becomes a terrible strategy. Now, the AI has a real incentive to only answer when it's sure and to just say, I don't know, when it's not. So the path forward is actually super clear. You tell the model the scoring rules right in the prompt, you make mistakes costly, and you make I don't know a perfectly safe, neutral answer. Suddenly, admitting uncertainty isn't failure, it's the smart play. So let's zoom out and put this all together. Why does some nerdy detail about AI test scores actually matter to the rest of us? It matters because we'll never have AI we can truly trust until we fix this. Right now, the entire AI industry is in a race to get the highest scores on benchmarks that actively encourage bluffing. If we want AI that's actually helpful, reliable, and safe, we have to flip the script. We have to start valuing honesty more than a confident-sounding guess. When you think about it, we've spent decades teaching machines how to talk. It's an incredible achievement. But maybe the next, even harder challenge is to teach them the wisdom of when to stay quiet. Can we build systems that don't just have knowledge, but also know the limits of their own knowledge? That really is the question that will define the future of AI.